Hello everyone, hope you are doing well. I am Sir Saeed Akhtar, and today we are going to solve a paper from 2023. This is paper 1 2 from May June 23. Without wasting time, I'm just going to solve these questions straight away. In question number 1, a stone sink in water, what is the possible value for the density of the water? It means if we have a water here and want to put a stone inside, the stone must be over there. It means the density of the stone must be greater than the density of the water. And you know that the density of water is 1000 kg per meter cube. So the option C and D are wrong because their units are not kg per meter cube. In these two options, this is 800 kg per meter cube and this is 2000 kg per meter cube. So the density of the stone must be greater, that is 2000. It should be greater than 1000. That's why option B is the correct option. The unit is, you know, that kg per meter cube. Question number 2. You have to write the largest and the smallest values of the prefixes. For the largest unit, the terameters are the largest one, and for the smallest is the micro, pico, yes, pico, but micro and pico is the smaller one. So this is the largest, the tera 10 is per 12, pico 10 is per minus 12. So option D is correct. Moving forward, in this question number 3, you have to write the density of a spherical body. So to get the density of a spherical body, the formula is mass over volume, but this volume is 4 over 3 pi r cube for a sphere, and you know that d by 2 is the radius. By substituting this value, it is 4 over 3 pi d power 8, sorry, d power 3 divided by 8. The cube of 2 is 8. Now this density is mass. For the volume we have 4 pi d cube 3 into 8. Now while finding the percentage uncertainty, we must ignore the constants. This constant 3, 8, 4, pi, these all are ignored. So the percentage I am writing in a short. The percentage uncertainty and the density is equal to 1. 1 is the power of m multiplied with the percentage uncertainty of m. So from this formula, the percentage is 0.1 multiply with 100 divided by the actual value. Then we add this uncertainty with the percentage uncertainty of d, but multiply with the 3 because the power of d is 3. 3 multiply with 0.04 into 100 divided by 1.87. As you know that we ignore these constants while finding the percentage uncertainty, as well as we will not change these units to standard units to the SA units, because in percentage uncertainties the units will be cancelled. So by solving this, the answer is 6.7%. Moving forward towards question number 4. In question number 4, you have two vectors. The force due to the wind, the thrust force of the engine, means these are the two forces and their tails are attached. Whenever we have two vectors, for example, we have the vector A and B, and someone asks to find the resultant must be over here. It means if two tails are attached, the resultant vectors will start from that point. It means the resultant of these two vectors must be at the center. That's why option C is correct. No other option is even close to the actual value. In question number 5, this is a semicircular track. Its radius is 1. There is a ball. This one is traveling from X and moving in this way. If we make it a circle for the better understanding, this distance is 1 and this distance is 1 again. So this whole distance is 2 meter. 2 meter. It means the shortest distance from this X to Y is 2 meter towards south. That's why 2 meter due south is the correct one. For this question, a rock is launched vertically upward from the surface of the Earth, and identical rock is launched vertically upward from the surface of Mars. It means we have a surface here, and bodies move upward in this way on Earth, and at here its velocity is 0, and then it will come back. Here the body moves up, the velocity is 0, and then moves down. For example, it's Earth and this is Mars. You know that the initial velocity we take is not equal to 0, because we always take the initial velocity just after the launching. So the initial velocity for Earth is this one. This value is 12, and this is the point where the final velocity is 0, and this time is required. This time is 1.2. So this area of the triangle will give us this distance d, this one. So to get this distance d, the area of the triangle is 12 multiplied with 1.2 divided by 2. Okay, for the mass, the initial velocity is again 12, and when this velocity is 0, this time is required. This time is 3.2 seconds. So if you get this triangle, means this triangle, we can have this distance d dash. So this distance d dash, these are not the scale diagrams which I have drawn. So it's 12 into 3.2 divided by 2, and by subtracting these two you can get the difference in the maximum heights. The difference in the maximum height is the difference between these two heights. So the first one is, just I have to solve it. Okay, is into 3.2 is it's 19.2, and for the other one, sorry, 6 into 1.2 is 7.2. So it is 19.2, and this one is 7.2. So by subtracting these two, the delta D is 12 meter. That's why option A is correct. We have done this question. For question number 7, which statement describe the mass of the object? Generally, the student relate the definition of the mass from this relation F is equal to ma. No, it's wrong. The mass relates with the law of inertia. So in this, the force of the object experience. No, the mass is not the force. It's wrong. You cannot define mass in the Coulombians and in terms of momentum change. The resistance of the object to change its motion. If we relate mass with the law of inertia or with the Newton's first law, then in fact the mass offers the opposition or the resistance in its change in motion. That's why this option C is the correct one. In option D, the weight, it means it's wrong again because the mass is not the weight. While finding question number 8, there's a submarine of the total mass is 3200 kgs rest in the underwater. If it is at rest, means the up and the downward forces are balanced. The total mass of the submarine suddenly decreased by 200 kg. It means now its mass is decreased from 3200 to 3000 kg. Now the new mass is 3000. The water out of the submarine horizontally at a negligible time. Okay, the upthrust acting on the submarine is unchanged. It means this force is unchanged as well. The change in the total weight of the submarine causes it to accelerate vertically upward. It means this downward force start decreasing. That's why it will accelerate upward. If it accelerates, means A is equal to F over M. Now we have to find the resultant force. The resultant force is because of this mass. This mass causes the resultant force because initially it was balanced. So this force is 200 multiplied with 9.81. This is the force, and the mass is now 3000. Let me solve it. This one is 1962 by 3000, and the answer is 0.654 meter per second square. That's why this option B is correct. Initially, the up and the downward forces are balanced. The upward force is upthrust, the downward force is the weight. When the upthrust is unchanged and the weight decreases, it means it starts accelerating upward, and the force due to which it's going upward is actually the resultant force obtained by this mass multiplied with 9.81 divided with the mass, that is now 3000. The acceleration is 0.654. For question number 9. In this question, a box in air slides with increasing speed down a rough slope from P to Q. It means this box is going to slide in this way, and its speed is increasing. It means it's going to accelerate downward. The slope surface exerts a constant frictional force. It means there is a constant frictional force that is called Fr is acting on it in this way, and it was sliding in air. It means there is another force other than this Fr, that is air resistance, which is also acting on it. These two forces are acting. One is this one, the frictional force, and other one is air resistance. Their direction is upward, up the slope. As the box moves from P to Q, there is a changes to the magnitude of the acceleration and the total resistive forces acting on it. Which to describe these changes? As you know that when it speeds up downward, this air resistance start increasing. When this air resistance start increasing, this whole sum is increasing definitely. So we can say that the magnitude of the total resistive forces increases. Got it? And now the magnitude of the acceleration. It means there are two forces acting on it. The downward force is the component of the weight, which is acting in this way. If this weight is over here, one of the component is in this way and the other component is in this way. If this is called angle theta, then this component is called mg sine theta. So mg sine theta is going to accelerate this mass downward. When this upward, the sum of this upward force means the total resistive force increasing, and this force is constant because the angle is same, it means the resultant force decreases. So if the resultant force decreases, it means the acceleration decreases as well. That's why the magnitude of the acceleration decreases, this one, and option D is correct. Now, this is a simple question. We have these two balls xy approaching each other straight and they collide. The collision is perfectly elastic. When we say that the collisions are perfectly elastic, it means the sum of the kinetic energies before collision is equal to the sum of the kinetic energies after collision. And number two, the sum of approaching velocity is equal to the sum of separating velocity. So here, the sum of approaching velocity is the sum of ux and uy, this one and this one, and the sum of approaching separating velocity is the sum of vx and vy. That's why option A is correct. So remember one thing, that if we have the perfectly elastic collision and two bodies are moving towards each other, their relative velocity will add on. If two bodies are moving away, their velocities will add on as well. But if two bodies are moving in the same direction, then their relative velocity will be subtracted. In question number 11, we have a rod is pivoted at point. This is the pivot. So this is simple one. Whenever you have to get the moments for this force, the angle between moment and the angle between the moment arm and the force must be perpendicular, means 90. This distance is moment arm and this is the action of the force, and they are perpendicular with each other. It means the force must be multiplied with this distance, that is OY. So we can have the moments. The angle between this moment arm and the force is 90 degree. For any other option, it's wrong. That's why option B is correct. F and the distance OY. Moving forward. Uh, Now, in this case, there's a force of 10 Newton is acting on this rod, and this force is downward, and there is another force which is acting upward. So we have to divide this F into the components. This one is called F sine 30, and this will produce the moments in this way, while this force will produce the moments clockwise. So the clockwise moments are the force multiplied with this distance, that is xy by 2, because the force is at the center, and is equal to this F sine 30 into xy, this perpendicular distance xy from the pivot. These two are now cancelled or with each other, and this is 5. So this F is equal to 5 Newton. This is the correct answer. No, this 2, no. This F is equal to 10 Newton. Moving forward, this there is a question number 13. So we have two solid cubes x and y. X and y are of the material of the same density. It means their densities are rho for x and for y. The cube X has twice the mass, sorry. So its mass is 2m, while its mass is m. The cube X has some sides, that is x, and this cube Y has the sides called y. And now you have to find the ratio between x and y. So for y, the density is equal to mass over volume. So it is mass divided by y cube, because if each side is y, then the volume is y cube. And the density of x is mass is 2m, and its volume, which is 2m over x cube. So if we cross multiply, x cube is equal to 2m over rho cube root, and cross multiply y is m over rho. So by substituting these values in x and y, this is 2m rho into this one. So by solving this, the answer is written, that is 1.26. So option A is correct. For question number 14. Now, what the difference in the pressure due to liquid between P and Q? So if we have some pressure at this point P, we have the same pressure at this point as well. So the pressures are same. So if we find the pressure difference from this to this point, that will be our answer. It means the pressure because of this height is required. So this height is in fact 4 centimeter. That's why the pressure is rho GH. In fact, delta P is rho G delta H. The density is 2000. The value of G is 9.81, and H is 4 centimeter. That is 4 into 10 raised to minus 2, because we convert centimeter into meter to get the SI unit. That's why delta P is equal to 780. 4 in fact, but the closest one with the 2 sig fig is 780 Pascal. This is the correct answer. Now question number 15. In this question, you have to find the efficiency of a turbine in fact. So this is the turbine. Its input power is Pi, the output is P naught, while this is the loss. While getting the efficiency, loss is not required. So density is P naught over Pi. And that's why option D is the correct one. So while finding question number 16, a variable force is applied to ensure that a constant power, means the power is constant, and there's a force F is applied and the velocity is V. So you know that the relation P is equal to FV, and if this is constant, then F and V are inversely proportional with each other. That's why this option A is correct. For question number 17. For question number 17, this body is moving downward, released from rest. It means the velocity is 0 at this point, the distance is x. So if the distance is x and there is a force acting on it to move it downward, is the component of the weight. So this component is in fact the component of the weight mg. If this is theta, then this is called mg sine theta. So the work done is in fact mg sine theta multiplied with distance x. And this work done causes the kinetic energy, that is half mv square. So this is work, that is Ft, and this is kinetic energy. So this m is subtracted and v is equal to cross multiply 2gx sine theta whole under root 2gx sine theta. That's option B is correct. The base of this question is in fact the law of conservation of energy, means there is a work done because of the force mg sine theta, and which causes the kinetic energy in the body, because the initial kinetic energy was zero. Here, what is meant by the spring constant of the spring? So you know that F is equal to KE, then K, this is K is equal to F over E, force divided by the extension. K is force per unit extension. Option D is the correct answer. Now, in question number 19, you know that there's a tension, means the force and the extension. A gust of the wind increases the tension from 100 to 150. So you have to get the change in the elastic potential energy. And the knowledge behind this question is the area of the force extension graph gives the energy. So this is the force extension graph, tension is force, and the force increases from 100 to 150. That's why this area is required. So to get this area, this is sum of parallel sides into base is the difference, that is 0.15 into 10 is per minus 3, converted from millimeter to meters, and divided it with 2 will give you the answer in joule, and then we will convert this answer to millijoule, or even you do not convert initially, you can get the answer straight away in the millijoule. Let me calculate this thing somewhere. It is 18.7. 18.7 means 19. This is the correct answer. Yes, it is right. For question number 20, okay, for this question, you know that in the CRO, this trace is for the CRO, this side is for the time, and this side is generally for the voltage. So which property of the sound wave can determine by using only the measurement of the horizontal distance on screen and value? The distance in this way means the horizontal distance will calibrate it to get the time, and you can find the time period. If you can get the time period, you can find the frequency, because F is equal to 1 by T. That's why we can have the frequency while getting the time along x-axis. The amplitude is wrong. We cannot find the speed in the wavelength because we have the time along x-axis, not the distance. That's why we are not able to get the wavelength. This is the correct answer. Moving forward, question number 21. This is done as well. Okay, a longitudinal wave is traveling from left to right. The graph shows the variation of the displacement of the particle with the distance along the wave 1 instant in the time. It means the displacement to the right are positive. This is positive, means right. Means the particles are moving in this way. These are the displacements, and at the top we have the maximum, and again it decreases in this way. and the displacement on the left is negative, means over there the displacements are on the left side. It means the displacement is this way, and like this one we have this type of a pattern. So which label point represents the compression? The compression means where the particles are getting closer to each other. So this is the point where the particles get closer, because at one side the particle wants to move towards right and the particle wants to move towards left, so they compress at this point. That's why option B is correct. Question number 22. You know that a sound X emits a sound wave. We have this source, sorry. Emits a sound wave of a constant frequency. The constant frequency is F. The wave is subsequently received at a stationary detector Y. This is the receiver or the detector. This frequency is received at this point. The frequency of the wave that is detected by Y is less than F. It means the frequency, this F dash, is less than the original frequency. It means the frequency decreases. And from the Doppler's effect, that if the frequency, received frequency, the observed frequency decreases, it means the source or the observer is moving away. That is in fact the X is moving away from Y, means this way. Yes, it's looking correct. The X is moving towards, no, this is wrong. That's why option C is correct. Means when this X is moving away, the frequency, the received, the observed frequency, this is the observed frequency, this one. Sorry, the sign must be in this way. This is in this way. The observed frequency decreases. Look at here. The frequency of the wave that is detected by Y is less than the original frequency. Yes, this is less than smaller frequency. It means the X and the Y are moving away to each other. This is the correct one. There is no diffraction. That's why these are wrong. This question was from the Doppler's effect. From the Doppler's effect, if source and observer are stationary, you have some frequency. If the source is moving away or the observer is moving away, the frequency decreases. And if any of them move towards each other, the frequency increases. So, in this question number 23, a beam of a visible light is in a vacuum. What could be the frequency for the visible light? If you know the spectrum, you know that the visible light is for the gamma, the frequency is 10^20 hertz. For X-ray it's 18, for UV it's 16, for visible it's 14. So this is the correct answer. This is the correct answer, but you can find it by the formula. You know that the visible light is from 400 to 700 nanometer. So from any number in between, you can choose the value from 400 to 700 and substitute this value to V is equal to F lambda, then F is equal to V by lambda, and V is the speed of light, that is 3 to 10 per 8, and this is the wavelength. So by calculation you can get the same answer. This is question number 24. So you know that initially the intensity coming towards this polarizer is I naught, and the frequency at this point is, you can say, I. You know the relation is I is equal to I naught cos square of theta. So for first one, this is I naught and this is cos square 45. The answer is I naught by, this is 1 by 2. Now the new intensity is I naught 1 by 2. It means now this intensity is equal to I naught by 2. And again its uh, transmission for the second filter is again 45 because it's 19 now, and the intensity is I dash, which is required after the second filter. So I dash is equal to I naught cos square theta. So now this is the initial intensity. It means it should be I naught by 2, that is cos square theta, and this is I naught by 2 and it is 1 by 2. So this should be I naught by 4. That's why option D is correct. For this 25, stationary waves is found by the two progressive waves traveling opposite towards each other. Means one wave is traveling in this way, the other wave is traveling in this way. Which statement about the two progressive waves is not correct? You know that the relation is V is equal to F lambda. That's why um, not correct. There must have a constant phase difference. Okay, there must have a same frequency. Yes, they must have the same frequency, and that's why they have the same speed, because they are same type of waves. That's why they have the same lambda, because this relation confirms it. It means they must have a constant phase difference is not the correct answer. That is not the correct requirement, and it is the correct answer because not required is the correct one. Now we have question number 26 here. In this question, you know that this is the point where we have node, and this is the point where we have node, and we have the anti-node at this point and at this point. So the distance between two consecutive nodes is half of the wavelength, that is equal to lambda by 2. So if we divide this, this is 20 and the 20 and 20 cm. So the whole length is 20. This lambda by 2 is equal to 40 cm. It means the lambda is 80 cm. While finding the frequency, you know f is equal to v by lambda. The speed is given, that is 340, and the wavelength is 80 into 10 to the power minus 2, because the frequency in hertz is required. So by solving it, let me check, let me solve it. This is 425. This, the answer is 425, that is 430 hertz. Option A is the correct answer. Okay, and while moving towards question number, yes, it is 27. Yes, 27. A continuous progressive waves in a ripple tank passes through a gap. It means we have some wavefronts like this one, and there is some gap here. The width of the gap is greater. This is the width which is greater than the lambda, the wavelength. It means we have less diffraction, minimum diffraction. Weight change causes the wave to spread over a large angle. Over a large angle means more diffraction is required. So to get the more diffraction, this distance A must be comparable with lambda. So we must decrease this lambda must decrease this A, the gap, or increase this lambda. A small decrease in the wavelength nodes, already small, that's why this is the wrong answer. A small decrease in the width, yeah, this is the correct answer. A small decrease in this gap A will make this gap comparable with lambda to get the more diffraction. Small increase in frequency, no, these are the wrong answer. Small increase in the height, there's no effect of height in diffraction. Question number 28. Okay, we have the double slit interference demonstration. Two waves are definitely going to interfere. Okay, the intensity I at the point on the screen where the center of the fringe pattern is formed. It means this is the center of the screen, which is always a bright spot having the constructive interference at this point, always. So it means if we have the wave coming in this way, and here the wave coming in this way, they have constructive interference. Okay, if we have the intensity I is equal to Ka square, so for the center the amplitudes are now added at this point, hence why the amplitude is double. That means it's 2A. So by taking the square, it is 4A square. If one of the filter is covered, means this filter is now covered. Intensity is required if one of the filter is covered. If one of the filter is covered, it means the amplitude is now single, means it's just A. For the new intensity I dash, the relation is Ka square, the simple one. So just put the value of K over here. So I dash is equal to K from this relation is I over 4A square into A square. So the answer is I by 4. That's why option D is the correct answer in question number 28. Let me confirm the answer. Yes, it is D. Question number 29. This question is related with the diffraction grating. Yes, this is. And you have to find the distance between the two adjacent slits, means D is required. From the relation, D sine theta is n lambda. D is required, n is the third order, and the wavelength is 550. It means this angle is not required. So we can have this angle because these two distances are known. Using any trigonometric relation, means theta is equal to tan inverse of perpendicular base 3.5. This angle is, let me check, it's 12.1. This angle is 12.1. So by substituting the value D multiply with 12.1, D multiply with sine of 12.1, and the order is 3. The wavelength is 550 into 10 raised to the power minus 9. So D is the correct answer. And after calculation, the D this is the correct answer, 7.9 into 10 raised to the power minus 6. Question number 30. Which charge can be carried by the charge carriers? It means the charge is always the multiple of the basic charge of the electron or proton. The basic charge E, the elementary charge, is 1.6 10 per minus 19 coulomb. It means the charge on any charge carrier is 1e, or it's 2e or 3e. The whole numbers mean it should not be 2.5e. That's why if we divide these charges with the basic charge, you can get the answer. It's a very simple one because it's 1.6 and it's 1.1 4.8. You can divide 4.8 10 is per minus 19 with 1.6 10 is per minus 19. 3. That's why this is the correct answer. These are wrong because when you divide this with the basic charge, you can get the whole number. Question number 31. In question number, there is a EMF of E, and this EMF E is attached with the resistor R this way. Now, which single change to the circuit would lead the largest increase in the power dissipation? A single variation is required. So, for this circuit, the power is E square over R. So, if we double the EMF, means double the EMF, the new power is 4E square by R. Double, and now by taking this square, it means P dash is 4 times of the initial power. Here if you double the resistance, it's inversely proportional. Wrong. Half the EMF, wrong. Half the R, wrong. The only answer is A. Moving forward, in question number 32, we have these wires attached with each other, and these wires are parallel with each other because the wires are in this way, they are parallel, and we are looking from their cross section. That's why they are parallel with each other. And these are 8 wires with a cross-sectional area of A, and one wire have a cross-sectional area of 4A. Their length is equal. The cable has a resistance of R. Okay, and they are parallel. So you know that R is equal to rho L over A. If these wires are parallel, then for the first wire, this is rho L A plus rho L A plus rho L A, and so on. So 1 over R is equal to rho L 8A. This is for the thin wires, but for the other, that is R is equal to rho L over 4A. And this R is equal to rho L over 8A. So we have these two resistors now, and we must add these resistors in parallel. So 1 over R, this R is in fact the total resistance, which is equal to 1 over R means rho L, and this is 8A plus rho L 4A. The LCM is rho L, so 8A plus 4A and R is equal to rho L over 12A, and resistivity is 12 R A by L. 12 R A by L. Option D is the correct one. So this is the question related with resistivity, resistance, length and area. Just look at this question again. We have these 8 wires with a thin start and the wire with a thick one. So in total we have 9 wires, and these all wires are in parallel with each other. So initially the sum of the 8 wire, the resistance for the sum of the 8 wire is this one, and the resistance for the one thick wire is this one, and their resultant is given as well. They are parallel because we are looking the cross section. That's why we add these resistance in parallel. So by taking LCM and then reciprocal and cross multiplying, because resistivity is required, that's why option D is the correct one. For question number 33. A car has a sensor detecting light. It means it has LDR and thermistor attached with it. You know that thermistor is a heat sensitive and LDR is a light sensitive resistor. The car moved from a warm and dark environment into a cold. It means from warm to cold, and from dark to bright. Right. So for the thermistor, you know that when its temperature increases, the resistance decreases. But here the temperature decreases, that's why the resistance should be increases. These two. And for LDR, it's from dark to bright, means more light shines. When more light shines on it, its resistance decreases. That's why option C is the correct answer. Question number 34. This is positive and this is negative. These are diodes from your previous O-levels knowledge. You must know that this triangle is considered to be the positive side and this line is the negative side. And now it is a forward bias. It can allow the current to flow. So when the current is flowing through it, the current will flow from this way, this and this. The current will not flow through this diode. But in both the cases, always lamp 1 and 2 will be going up, because lamp 1 and lamp 2 is always on, because this diode and this diode will allow the current to flow. Option D is the correct one. Moving forward, Kirchhoff's first law is the consequences of the conservation of the physical. Kirchhoff's first law follows the law of conservation of charge. So the conservation of which quantity means which physical quantity is going to conserve. Charge is always conserved in the Kirchhoff's first law, and in the Kirchhoff's second law, the voltage is conserved. Means the energy is conserved, W by Q. For this question number 36. Now here we have 3 cells attached with each other, and a negligible internal resistance and identical 3 resistors are attached having resistance R. So if we get the EMF, this positive is attached with the negative. So these EMFs are cancelled with each other. The only remaining EMF is E to operate this circuit. E. And this is equal to the voltage of these resistors. They are in series, that's why their combined resistance is 3R, and The voltage is V is equal to IR. It means I into 3R. What is the potential difference across one of the resistors? So the resistance is E by 3 is equal to IR. This is the voltage against any resistor. That's why option B is the correct answer. Now question number 37. Here we have these two resistors in series, and there is a uniform metal wire offering some resistance, and the contact slide is over here. The LDR is then covered and the ammeter gives a non-zero reading because initially it was showing 0. LDR is now covered. It means less light is falling on it. That's why its resistance increases. If its resistance increases, voltage increases, and its voltage decreases because there's some V1 and V2, their sum must be equal to the power supply, which is constant. Now, which change could return the ammeter reading to 0? It means the voltage of LDR and the voltage of this portion must be same, and the voltage of V1 and the voltage for this portion must be same because they are parallel. That's why the ammeter is showing 0 value. If its voltage increases and we move this contact somewhere over here, we can have more resistance here, and hence the voltage increases and become equal to this voltage, and ammeter shows 0. It means when we move this sliding contact towards left, we can get ammeter 0 again. Decreasing the power supply wrong, increasing the supply wrong, moving the sliding contact to the left, this is the correct answer. And moving the sliding contact to the right is wrong because when we move it towards right, the voltage decreases and we can have the more potential difference, and ammeter will not show 0. What are the isotopes? Nuclei of the different element, no, it's wrong. Different, it's wrong. Nuclei of the same element. Nuclei of the same element with the different number of neutrons, yes, it is the correct one because the neutrons are different, the mass number is different, and it's wrong as well. Forward. Here we have question number 39. A neutron is fired on the uranium-235. It means their sum is 236 and the sum of the mass number is 92. And these are the splitting nuclei, the two new nuclei. By adding 56 with 32 we have 92, it means it's same, but adding 92 with 141 will not give you 236. It means N12 plus uranium 235 92 gives barium 141 56 plus krypton is 9236. 92, that's 1 and 0, it's 92 and it's 236, but these are not 236, these are 233. See. 9. Okay, right. It means 3 more neutrons are required to balance this. It's 236 and it's 233. So if we have 3 neutrons, then we can have this equation balanced. It means 3 neutrons will be emitted. It is 9236. Okay, in question number 40, we have a pi meson, the positive, has this charge. So is elementary. It consists of one up and one other. And what could be the other quark? We must write the name of the other quark. You know that up, down, charm, strange, top, and bottom. These are the quarks, and their charge is plus 2 by 3e, and it's minus 1 by 3e. It's again plus 2 by 3e. It's minus 1 by 3e. It's plus 2 by 3e, and it's minus 1 by 3e. So one charge is known, that is up, and its charge value is plus 2 by 3e. And other quark is required to add over here. Okay, if we add it with the minus 1 over 3, the answer will not be E. And if we add with 2 by 3, the answer will not be either. So if we have to have the anti-quark of this, the anti-quark of down is plus 1 by 3e. So if we have anti-quark, that is plus 1 by 3e, then by taking the LCM, it's 2e plus 1e, means 3e by e is equal to plus 3. That's why we can have this net charge. It means this is the correct answer. Anti down is required. Option A. Thank you very much.